Good morning. It's March 25th, and this is your daily brief in science. Here's everything you need to know. NASA's Curiosity rover has made a groundbreaking discovery on Mars, detecting the longest organic molecules ever found on the planet. This finding suggests that prebiotic chemistry on Mars may have been more advanced than previously thought. The organic compounds were identified from a rock sample known as Cumberland, collected from the Gale crater, which was once part of an ancient lake. The identified molecules include decane, undecane, and dodecane, believed to be remnants of fatty acids essential for cell membranes in living organisms. Researchers hypothesized that these compounds originated from longer-chain fatty acids and confirmed their predictions through laboratory experiments. Interestingly, this discovery emerged from an experiment aimed at detecting amino acids, which were ultimately not found, leading to the identification of these larger organic molecules instead. While fatty acids can be produced by living organisms, they can also form through geological processes, raising questions about the source of the detected molecules. Research published on March 24, 2025, indicates these large carbon molecules have been preserved on Mars for approximately 3.7 billion years, due to the planet's lack of geological activity and harsh climate. This finding adds to the intrigue surrounding Mars's potential for ancient life and emphasizes the importance of continued exploration and analysis of its geology. The research, funded by NASA's Mars Exploration Program, highlights the necessity for future Mars sample return missions to conduct more detailed analyses on Earth. Future exploration missions, including the European Space Agency's ExoMars mission set for 2028, will utilize techniques developed by Curiosity to search for signs of life on Mars. Dr. Caroline Freycinet, the lead author of the study, noted that chemical signatures of past life could potentially be detected in Mars samples, fueling the ongoing quest for extraterrestrial life. A historic achievement in lunar exploration has just unfolded. The Chang'e-6 probe, launched in early May 2024, successfully returned to Earth with nearly 1,935 grams of lunar material on June 25, 2024. This mission is particularly significant as it provided the first direct rock samples from the Moon's South Pole Aitken Basin, the largest and oldest known impact crater on the Moon. Located on the far side, the SPA Basin is believed to have formed during a period of intense asteroid bombardment that shaped the early solar system. Recent geological studies led by Professor Chen Yi have established that the SPA Basin formed approximately 4.25 billion years ago, clarifying its role in lunar history. The analysis of norite clasts from the samples indicated they crystallized from a common impact melt sheet generated by the SPA impact, confirming the basin's formation age. Researchers meticulously examined around 1,600 fragments from the lunar soil samples, isolating 20 norite clasts that exhibited textures and mineral compositions consistent with an impact origin. Using lead-lead isotopic dating on zirconium-bearing minerals within these clasts, the team identified two significant ancient impact events, one at 4.25 billion years and another at 3.87 billion years. These findings refine the lunar cratering chronology and enhance our understanding of the dynamic processes that shaped the early solar system. Prior to this research, the precise age of the SPA Basin was largely unknown, with estimates varying widely, complicating its significance in lunar and planetary evolution. Published in the National Science Review, on March 21, 2025, this comprehensive study underscores the importance of direct sample analysis in advancing our knowledge of lunar geology. Overall, this research represents a significant advancement in understanding the Moon's geological history and the broader context of solar system formation. Scientists at Imperial College London are breaking new ground by training dogs to detect harmful bacteria, specifically Pseudomonas. This bacterium poses significant health risks, particularly for patients with cystic fibrosis, where it can lead to severe pneumonia and sepsis. Professor Jane Davies is leading this initiative, highlighting that trained dogs can identify Pseudomonas in patient samples, which is crucial for timely medical intervention. One of the standout participants in this project is Jody, a golden Labrador, who has demonstrated the ability to detect specific bacteria. This innovative approach utilizes non-invasive samples like skin, urine, or clothing, making the detection process more comfortable for patients compared to current methods that are often invasive and costly. The need for more efficient alternatives is evident, as existing detection methods can be uncomfortable and may not always yield accurate results. By employing these trained dogs, the project aims to provide a less invasive and more effective means of detecting bacteria, addressing the limitations of traditional methods. In the long run, the detection system developed could extend beyond cystic fibrosis patients, potentially benefiting other patient groups and broadening its impact. Early identification of bacteria through this method is essential for precise antibiotic prescriptions, which is increasingly critical in the fight against antibiotic resistance. With approximately 1 million deaths annually attributed to antimicrobial resistance and rising mortality rates affecting older populations, innovative solutions are necessary. Professor Davies emphasizes the role of trained dogs like Jody as valuable allies in this ongoing battle. The project is supported by funding from LifeArc and the Cystic Fibrosis Trust, in collaboration with medical detection dogs, aiming to enhance the capabilities of dogs in detecting Pseudomonas in patient samples. A remarkable breakthrough in medical science has emerged from Japan, where a fully paralyzed man has regained the ability to stand and walk following a spinal cord injury. This achievement is the result of a pioneering treatment involving a single injection of reprogrammed neural stem cells, led by stem cell scientist Hideyuki Okano at Keio University in Tokyo. The trial included 4 patients who had recently become paralyzed. Each participant received 2 million neural precursor cells shortly after their injuries, accompanied by immune-suppressing drugs for 6 months post-surgery. This innovative treatment utilized induced pluripotent stem cells, which are adult cells reprogrammed to function like embryonic stem cells, facilitating their development into neural precursor cells injected into the injury sites. Okano's research has received backing from the Japanese government since 2019, following earlier successes in monkey trials. The significant recovery of the patient, who can now stand independently and is training to walk, underscores the potential of stem cell research in regenerative medicine. However, experts caution that more extensive trials are needed to determine definitive results. At the 1-year follow-up, while no serious adverse effects were reported, 2 participants did not show improvements in sensory or motor functions. One participant improved to a classification of C and another to D on the American Spinal Injury Association impairment scale. The participant who improved to level D has demonstrated a remarkable recovery, as noted by Okano. Researchers have indicated that the treatment appears safe, generating excitement in the field of regenerative medicine. According to translational neuroscientist James St. John from Griffith University, preliminary analysis suggests that the treatment may be effective, but larger trials are necessary to confirm these findings and rule out natural recovery as a factor. St. John emphasized the need for further research to assess the effectiveness of induced pluripotent stem cells across various types of spinal injuries. A new olfactory test developed by researchers at Mass General Brigham may change how we detect cognitive impairment, particularly Alzheimer's disease, right from the comfort of home. This innovative approach allows for early identification of cognitive issues through smell tests that can be easily administered by individuals themselves. The study included participants from various backgrounds, specifically targeting English and Spanish-speaking individuals who reported cognitive complaints or had mild cognitive impairment. Participants undertook at-home smell tests designed to evaluate their ability to identify and remember different odors. Findings revealed that older adults with mild cognitive impairment had significantly poorer performance in odor identification and discrimination compared to their cognitively healthy counterparts. Notably, the test results showed consistency across different language groups, and performance was unaffected by whether participants were being observed by researchers. The research highlights the connection between subtle olfactory dysfunction, or a diminished sense of smell, and the potential onset of neurodegenerative diseases like Alzheimer's and Parkinson's. To gauge participants' olfactory capabilities, The Aroma Brain Health Test was employed, a tool developed by a company co-founded by senior author Mark Albers. Albers pointed out the importance of early detection in identifying individuals at risk for Alzheimer's, advocating for timely interventions prior to significant memory loss. Future research is expected to integrate neuropsychological testing and longitudinal studies, aiming to further assess the predictive capabilities of olfactory testing in monitoring cognitive decline. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.